Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video we finished and eliminated with chapter number 3 exercise number 3.3 which chapter number 3 has been completed. In today's video I am going to solve some of the MCQs based on chapter number 3 related with Etea Mcqs related with Mcqs series. So let's move toward MCQ number first part, chapter number 3 higher order derivative application FSC part 2 mathematics. MCQ number first of Mcqs series is find d power 77y divided by dx power 77. 77 means that we will find the derivative up to 77 term if y is equal to cos of 5x. So we have a function given y is equal to cos of 5x. So there let's suppose first time derivative will be minus 5 into sine 5x. And the second time derivative for this function will be this 5 will again multiply, so it becomes minus 5 over 2 sine 5 derivative is cos of 5x. And for the third time derivative it will be cos 5x again negative, so negative gives us plus, and over here we have 1 5 and 2 5, so it becomes 5 power 3 into sine 5x. And for the fourth time derivative it becomes 5 will again multiply, so it becomes 5 power 4 into cos of 5x. And for the fifth time derivative it will again minus time of 5 power 5 into sine 5x. So over here we are tracking and dealing with the odd term. So over here if I suppose this odd term just like this, y power n is equal to minus 5 power n into sine 5x. So what will be the derivative of this function for the 77th term? So the derivative for this function, or we can also take for this function, if we suppose to be taken the derivative of this function again, so it become y power 6 will be derivative of sine is again cos of 5, so it become minus 5 power 6 into cos of 5x. So let's suppose this is our nth term, so y power n is equal to minus into 5 power n into cos of 5x. So if I suppose to be taken 77 over here, so it become y power 77 will be equal to minus 5 power 7 into cos of 5x. So this is actually the general term in which we actually find 77 derivative of the function. So our result will be minus 5 power 77 into cos of 5 is the correct option, is option number B. Now move to the next MCQ. MCQ number 2, equation of normal to the curve y is equal to ln of x square at the point minus 4 1 will be. So taking the given function and the given curve y is equal to ln of x square. Now using the rule of logarithm, that log of n to the base m will be equal to n log of m. So this power will come to the front of natural logarithm, so it becomes y is equal to 2 into ln of x. Now take the derivative of both sides, so y dash will be equal to dy by dx will be equal to the slope m will be equal to 2 multiply ln x derivative is 1 over x. And our x is actually minus 4, so it becomes 2 divided by x is minus 4, so it will give the slope minus 1 divided by 2. Now using the equation of normal to the curve, y minus y1 will be equal to minus 1 over m into x minus x1. So it becomes y minus y1 is actually 1 will be equal to minus 1 over m. M is actually minus 1 by 2 into x minus x1. So here it is minus 4x1, so minus minus will give us plus 4. Now it becomes y minus y1. This will move to the numerator, minus will cancel out with minus, gives us 2 into x plus 4. So by simplification it becomes y minus y1 will be equal to 2x plus 8. So our y will be equal to 2x plus 1 plus 8 will give us 9. So in the option we have 2x minus y. We can also write in the form of 2x minus y plus 9 is equal to 0. So 2x minus y, this is the option. Y will shift to the right hand side, becomes minus y plus 9. So 2x it shift to the right hand side, minus y and plus 9. 2x minus y plus 9 is equal to 0. Option number A is the right option. Now move to the next MCQ. MCQ number 3. If x is equal to a cos of t, y is equal to b sin of t, then double time derivative of y with respect to x will be. So move toward the solution of this problem. This is actually the parametric differentiation, which is equal to dy by dx will be equal to dy by dt multiply dt by dx. So first we will differentiate y with respect to t. So our dy by dt will be, it will give us b cos of t, and differentiating x with respect to t, so it gives us dx by dt will be equal to, over here we have a cos of t, so cos of t derivative is negative sin t, becomes minus a sin of t minus a sin of t. And now putting the values over here, so it becomes dy by dx will be equal to dy by dt, which is equal to b cos of t. Multiply dt by dx. Over here we have dx by dt, so reciprocating, it will also reciprocate. So it becomes dt by dx, so they will reciprocate, it becomes minus 1 over a sine of t. So this is dt by dx, putting over here minus 1 over a into sine of t. So it becomes dy by dx will be equal to b by a and minus, so it becomes minus b by a. Cos by sine will give us cotangent t. This is actually the first time derivative. For the second time derivative, we have formula that d square y by dx square will be equal to d by dt of derivative of the first function divided by dx by dt. Using this formula and get the required result. D by dt of dy by d is this function derivative. So minus b by a is a constant, and multiply derivative of cotangent t is actually minus time of cosecant square t divided by dx by dt. Dx by dt is actually minus time of a into sine of t. Minus cancel out with minus. This a is in division, this is also in division, they will multiply with each other. And this minus will come to the front, so it becomes minus time of b divided by a into a will give us a square. 1 over sine is actually cosecant. Cosecant multiply cosecant square will give us cosecant cube time of t. So this is actually the required second time derivative. Minus b by a square into cosecant cube t. Over here we must have a negative sign, so the correct option will be option A. Now move to the next MCQs. MCQ number 6 of function cosecant. We skip the two questions because the two questions were totally related with chapter number 4 that inshallah we will solve in the next video, differentiation of a vector function. That's why we skip the two questions. Let's move to our question number 6 of function cosecant x is increased in the interval. We have 4 options given. So we take the given function f of x is equal to cosecant x. For increasing and decreasing past differentiation, we will differentiate the given function. So f prime of x will be cosecant x derivative is minus cosecant x and cotangent x. Now we are going to find the critical values for which we make the first time derivative is equal to 0. So it becomes minus cosecant x into cotangent x. So it means that we are either cosecant x is equal to 0 or either cotangent x is equal to 0. You know that cosecant x will be equal to 0, so it means that the value of x is 0 because cosecant 0 gives us 0. The solution is 0. And from over here we write cos x divided by sin x is equal to 0. So it will give us a value of cos x is 0, and cos x is 0 when the angle is pi by 2. So the solution is x is equal to pi by 2. It means that the function is increased in the interval 0 to pi by 2. So the correct option is option number B. Now move to the next MCQs. MCQ number 6 of function cosecant. We skip the two questions because the two questions were totally related with chapter number 4 that inshallah we will solve in the next video, differentiation of a vector function. That's why we skip the two questions. Let's move to our question number 6 of function cosecant x is increased in the interval. We have 4 options given. So we take the given function f of x is equal to cosecant x. For increasing and decreasing past differentiation, we will differentiate the given function. So f prime of x will be cosecant x derivative is minus cosecant x and cotangent x. Now we are going to find the critical values for which we make the first time derivative is equal to 0. So it becomes minus cosecant x into cotangent x. So it means that we are either cosecant x is equal to 0 or either cotangent x is equal to 0. You know that cosecant x will be equal to 0, so it means that the value of x is 0 because cosecant 0 gives us 0. The solution is 0. And from over here we write cos x divided by sin x is equal to 0. So it will give us a value of cos x is 0, and cos x is 0 when the angle is pi by 2. So the solution is x is equal to pi by 2. It means that the function is increased in the interval 0 to pi by 2. So the correct option is option number B. Move towards MCQ number 7. A function is said to be increasing if it follows these 4 conditions. Remember, the function will be increasing if single prime derivative of x means the first time derivative is greater than 0. So the correct option will be option B. For the decreasing, we will choose the option number 8, f prime of x less than 0. Move toward MCQ number 8, in which interval f of x is equal to x square is increasing. Remember, for the increasing and decreasing function, we will first differentiate the given function. Our f of x is equal to x square, so first time derivative is f prime of x is x square, derivative is 2x. Now check at the interval minus 1 and minus 1. Let's suppose at interval minus 1 I supposed to be taken minus 1. So by putting minus 1 over here it gives us minus 2. It is less than 0, the function is decreasing for part number D. This is not the right option. Now postulating option number C, f prime of 2. Let's suppose we have these interval 1 to 10. 1 to 10. I supposed to to be taken to in between 1 and 10. I can take and choose any number in between 1 to 10. Let's suppose I take 2. By putting 2 over here into 2x, so it gives us 4. It is greater than 0, it means the function is increasing. So correct option is option number C. Part number B, we have minus 2 to 1. Minus 2 to 1 is supposed to be taken 0 or either minus 1. So if minus 1, it gives us less than 0, the function is decreasing. And a prime of 0, in the interval 1, this is also the wrong option. Part option number A, minus 1 to 2. Minus 1 to 2 is supposed to be taken 0. So at 0 gives us 0, it is neither increasing nor decreasing, but so the correct option over here and the correct answer will be neither increasing nor decreasing. So the correct option will be option C, and at this interval the function is increasing 1 to 10. So the correct option is option C for the MCQ number 8. Now move toward MCQ number 9, in which interval f of x is equal to x cubed is increasing. 4 options are given. So let's suppose in this interval minus 1 to 2, in this interval let's suppose I take 0. So first of all, differentiate the given function f of x is equal to x cubed, which gives us 3x squared. So let's suppose this is the differentiation of this function. Let's suppose in between minus 1 and 2, I is supposed to be taken over here, we can also take 1. So in this interval, let's suppose I take 1. So by putting 1 over here, it becomes a 3 into 1 square. It gives us a value 3, which is greater than 0. It means this is increasing function, increasing interval. Now selecting option number B, minus 10 to 10. Minus 10 to 10, if I take any number, either positive or negative, here it is square, so it will make that number positive. So this is also greater than 0, so this is also increasing function. And for 0 to 30 interval, from 0 to 30, all the numbers are positive. So by putting any number positive over here, it will give again a positive number greater than 0. It means that all option will increasing by interval. So the correct option will be option number D. Move to the next MCQ number 10, in which interval f of x is equal to sin x is increasing. 4 options are given. Remember, for increasing, we will first derive the given function. So f of x is equal to sin x, derivative will be f prime of x will be equal to cos of x. For increasing function, the definition is the first time derivative must be greater than 0. First time derivative is cos x, so cos x must be greater than 0. For the option A, let's suppose in between 0 to pi, I select pi by 2. So by putting pi by 2, it gives us 0, which is not greater than 0. This is against the definition of increasing function, so this is the wrong option. And for option number B, 0 to pi by 2, let's suppose I take the middle value of this function, which is pi by 4. So cos pi by 4 is 1 by root 2 greater than 0, and 1 by root 2 is 0.86, which is later greater than 0. It means there's defined the given function, which is increasing. And for part number C, if I is supposed to be taken 5 by 2, 5, let's suppose I take the number in between this interval 2 pi by 3, which is equal to cos of 140 degree. Cos 120 degree is minus 1 by 2, which is not greater than 0. It's also against the definition of increasing function. This is the wrong option. And for this option, let's suppose I take minus pi, so cos minus pi will be cos pi, and cos pi minus 1 greater than 0. This is also against the definition. So the right option will be option number B for the MCQ number 10. Now move toward MCQ number 11. A function is said to be decreasing if it defined option number C. Remember, we already learned in the previous MCQ that f prime of x will be less than 0 for the decreasing function. And for the part number A, this is defined decreasing function, but this is only for relative minima greater than 0. So this is not the right option. And this is for the point of inflection, and this is already for increasing function. So the correct option is option C. 12 number MCQ said that a point at which f double prime of x has a maximum or minimum value will be called critical point. So through the critical point, we can find the maximum value, minimum value, increasing and decreasing function. So the correct option is option B. MCQ 13, a point in which f double prime of x is equal to 0 and f triple prime of x will not be equal to 0. This type of point will be called point of inflection, part number B. MCQ number 14 is a function f of x has a maximum value at x is equal to x naught if it defined the definition just like B. F double prime of x naught must be less than 0, so this will be called a maximum value and relative maxima. And for f double prime of greater than 0, this will be called a relative minima. But they are talking about maximum, so the correct option will be option number B. Now move toward MCQ number 15. In the interval 0 to 5, the function f of x is equal to sin x has a maximum value at 4 options are given. Remember, at sin x, so at 0, it will give us a value 0. At pi by 3 is actually 60 degree, and sin 60 degree is under root of 3 divided by 2, which gives us a value 1. It will give us under root 2 is actually 1.4. It will give us 1.8 divided by 2 will give us a value 0 point something, 0.75 is just like this, and pi by 4 is actually sine pi by 4 is 1 over 2, which is actually 0.866, and sine pi by 2 sine 90 gives us 1. So the maximum value sine gives us at pi by 2, which is actually 1, which is greater than 0, 0.7, 0.6. So correct option is option number D. And MCQ 16 is nth derivative of a power mx will be. Let's suppose this is equal to a function y, a power mxo. So first time derivative will be a power mxo and ln of a, and derivative of this function will be m. Now for the second time derivative, it becomes this is a constant ln of a dot m, and derivative of this function will be again a power mxo into ln of a, and derivative of the inner function will be m. So it can be written as just like this, m into m gives us m square, ln a into ln a gives us ln of a whole square into a power mxo. So the inner derivative will be y power n is equal to m power square is again repeating, so we can write n. This square is again repeating, we can write n, and a power mx. So this is actually the nth derivative, m power n, a power mx, and ln of a power n. So the correct option is option number B. Now move toward MCQ number 17. If y is equal to ln of sine x, find double derivative of y. So for the first time derivative, y dash will be ln sine x derivative is 1 over sine xo, and derivative of the inner function sine x is cos xo. So cos x by sine x gives us cotangent x. This is first time derivative. For second time derivative, y double dash will be cotangent x derivative is minus cosecant square x. So this is the second time derivative minus cosecant square x. This is the wrong option. This is wrong. This is wrong. The correct option will be none. Option number D. MCQ number 18 tells the function whose series is represented by 1 plus x square by 2 factorial plus x power 3 by 3 factorial plus x power 4 divided by 4 factorial. This is the Maclaurin series expansion of which function? The correct option is e power x. How e power x? You can watch my video to go to my playlist in my YouTube channel, Calculus and Mathematics Learning. So in higher order derivative playlist, you will easily watch the Maclaurin series expansion of e power x, which gives us this series. Move toward MCQ number 19. Maclaurin series expansion of cos x is represented by 4 options are given. Our Maclaurin series formula is f of x is equal to f of 0 plus x prime of 0 plus x square by 2 factorial f double prime of 0, and goes on. So f of x is cos x. By putting x 0, if it gives us cos of 0 gives us 1. And f prime of x derivative of this function is negative sine x. By putting 0, it gives us 0. F double prime of x minus sine x derivative minus cos x. By putting x 0 gives us minus cos of 0 gives us minus 1. F triple prime of this function will give us sine x. By putting x 0 gives us 0. F 4 time of derivative of sine x cos x, and putting again 0 gives us 1. Putting value in the formula, f of 0 is 1, so putting 1. Plus x into f prime of 0 is 0, so it gives us 0 whole term is 0. Plus x square by 2 factorial into f double prime of 0. F double prime of 0 is minus 1, this also 0. And plus x power 4 by 4 factorial, 4 time of derivative is 1. So it gives us 1 minus x square by 2 factorial plus x power 4 divided by 4 factorial, and goes on. So the correct option is option number A. Now move to the next MCQ number 20. Equation of tangent line and the curve y is equal to 4 minus x square when y crosses the x-axis. Y crosses x-axis means that y coordinate is equal to 0, so y is 0. So by putting y 0, it will give us the value of x plus minus 2. Now take the derivative of this function, it will give us minus 2x. By putting x plus minus 2, it will give us dy by dx slope plus minus 4. Y is equal to mx plus v. This is the equation of tangent line. We are finding c from over here. Y is 0, m is plus minus 4, x is 2, so over c is plus minus 8. Putting the value m is plus minus 4, which is dy by dx, into x plus minus c is 8. Plus minus 4 is common inside, we are left with x plus minus 2. So this is equation of tangent line. The correct option is option number B. Move toward MCQ number 21. A function phi into x naught, f of x naught, and the graph of differential function where the concavity changes is called will be maximum point, minimum point, point of inflection, D is none. Let's suppose this is the graph. The starting point is called maximum point, and the point in which the function or the graph stop, their point will be called minimum point. And when the second time the function goes upward, then the second time derivative over here d square y by dx square is equal to 0. So when the second time derivative is 0, their point will be called point of inflection. So the correct option is option C. And 22 MCQs, if a function has a point of inflection phi into a into f of a at a point A, and it is possible to differentiate the function twice, then it follows the condition option number C. You already done over here. The second time derivative of a function at a point A will be equal to 0. Now move toward MCQ number 23. Critical values of the function f of x is equal to x cubed by 3 minus x squared minus 15x plus f will be. Differentiating the given function, the power will come to the front 3 and subtract 1 in the power will become 3x squared divided by 3 minus x squared derivative is 2x so, and 15x derivative is minus 15 derivative operator 0. 3 is cancelled out with 3, we are left with x squared minus 2x minus 15. For critical point a prime of x will be 0, so 0 is equal to x squared minus 2x minus 15. Do factorization over here, so x into x minus 5 plus 3 into x minus 5, the value of x will be minus 3 and 5, so the correct option is option A. Move toward MCQ number 24. If a function f of x is equal to x cubed minus 3x plus 1, then the function f of x at x is equal to minus 1 will be. If we put x minus 1, it will become minus 1 cube, minus 3 into x is minus 1 and plus 1. Minus 1 cube gives us minus 1, it gives us plus 3 and plus 1. 1 cancel out with negative 1, we are left with 3. 3 is greater than 0 positive, it means that it gives a maximum value. Correct option is option B. We skip all the MCQs from 25 to 32 because these were related with chapter number 4, differentiation of a vector function, that we will learn in the next videos. So 33 tells that if y is equal to sin x plus cos of 2x, where 0 less than x less than 5, then the stationary value of y will be. First we differentiate the given function, so y dash will be sin x derivative is cos x, sin cos 2x derivative is minus 2 sin 2x, y dash will be cos x minus 2 into sin 2x is 2 sin x cos x, so cos x is taken out common, we are left with 1, and over here take out cos x common, we are left with minus 4 sin x, so it means that for the critical point cos x is 0 and 1 minus 4 sin x is 0. Cos x is 0 when the angle is pi by 2, so the correct option is option number B. Toward MCQ number 34, if f prime of c is equal to 0 or f prime of c does not exist, then x is equal to c will be called, that c point, that c will be called a critical value of the given function. So option number B is the right option. If f of and MCQ 25, if x is equal to c is any value in the domain of a function f, and f prime of c is equal to 0 or either does not exist, so then the point PC into f of c will be called critical point. So the correct option will be option number A. In MCQ number 36, so if f prime of c is equal to 0 and f prime of x is greater than 0 before x is equal to 0 and f prime of x is less than 0 after x is equal to c, so we will look over here, if it is less than 0, it means that the function will be maximum value. So the correct option will be option number A. And over here, if prime of x is greater than 0, then the function will be a minimum value. So the correct option is option number B. Now move toward MCQ number 38. If f prime of c is equal to 0, f prime of x less than 0 before x is equal to c, and f prime of x is greater than 0 after x is equal to c, then which of the following is true? Over here, before x is equal to c, the f prime of x is less than 0. It means the function is decreasing over here. And after this, the function is also decreasing. It means neither change is occurring. So it means there will be an inflection point at x is equal to c. So the correct option will be option number C. Move toward MCQ number 39. Which one of the following is a point of inflection of a function f of x is equal to 1 minus x cubed? 4 options are given. For the point of inflection, first we take the derivative first time. So first time derivative of this function is minus 3x squared. Then we will take second time derivative will be equal to minus 3x squared. Second time derivative is minus 6x. So for the point of inflection, we make the second time derivative equal to 0. So y dash will be equal to 0 minus 6x. So the value of x is 0 from over here. By putting the value of x 0 from over here in the original function, so it becomes 1 minus 0 cube, which gives us a value of y1. So our 0, x will 0 and y will 1. So the correct option will be option number B. Move toward MCQ number 40. The function f of x is equal to x squared plus 3x plus 2 is increasing in the interval. 3 and 4 options are given. We will take the given function f of x is equal to x squared plus 3x plus 2. Function will increase if it define the definition f prime of x will be greater than 0. F prime of x is actually the first time derivative of the given function. So f of x is x squared plus 3x plus 2. Its derivative will be f prime of x. X squared derivative is 2x and 3x derivative is plus 3. Putting the value of f prime of x in this definition. So f prime of x is 2x plus 3 greater than 0. Shift 3 to the right hand side, it becomes 2x greater than minus 3. So the value of x will be greater than minus 3 by 2. The interval notation will be minus 3 by 2 to greater than means the function will goes toward positive and infinity. So the correct option will be minus 3 by 2 to infinity. The correct option is option number A. Move toward MCQ number 41. Maximum value of the function y is equal to sin x plus cos x will be. Our given function is y is equal to sin x plus cos x. Take the first time derivative, so y dash will be sin x derivative is cos x. Cos x derivative is negative sin x. For the critical point, y dash will be equal to 0. So 0 is equal to cos of x minus sin x. Sin x will shift to this side, it becomes sin x is equal to cos x. Sine divided by cos will give us tangent x is equal to 1. So tangent x is equal to 1 when the value of x is pi by 4. So putting the value for the maximum value, put x is equal to pi by 4 in the original function. So y will be equal to sine of x is pi by 4, sine pi by 4 plus cos of pi by 4. Sine pi by 4 is equal to under root 2 by 2 plus cos of pi by 4 is also equal to under root 2 by 2. Taking LCM, it becomes 2 root 2 divided by 2. Root 2 will cancel out with 2b, or that is y is equal to root 2. So the correct option will be option number A. Now move to the next MCQ. MCQ number 42. Function f of x is equal to sin x is decreasing in the interval. More options are given. Remember, our function is f of x is equal to sin x, and you also know that derivative of f of x is equal to sin x will always be equal to f prime of x derivative of sin x cos x. For the decreasing function, this definition must be satisfied. F prime of x will be less than 0, or f prime of x is actually cos of x, which is less than 0. Remember, in between this interval, if we take let's suppose cos of 2 pi by 3. So cos of 2 pi by 3 will give us minus 1 by 2, which is less than 0. So this is defined, this function defined. And if we suppose minus 2 by 3, minus 2 pi by 3, so cos of minus 2 pi by 3 less than 0, it gives us a cos of 2 pi by 3, because this is an even function. Cos of 2 pi by 3 again minus 1 by 3 less than 0. So these both options satisfy the given function, so the correct option will be option number C. Now move to our MCQ number 43. Which one of the following is true? Part number A is every critical point is a stationary point, and part number B is every point of inflection is a partition point, and the last part is every partition is a point of inflection. This is a wrong option. Every partition point is not necessary to be in a point of inflection, and this is a right option. Every point of inflection must be a partition point, and you know that every critical point is a stationary point. This is also the right option, so the correct option will be option C. And more terms are used in the Taylor polynomial, then we obtain a more accurate result and less precision. Because if we use more and more terms, then the point will be more, the value will be just like this, 0, 0, 0, 0, 1. So the least count will be increased and the precision will be decreased. So precision will be less and the result will be accurate. So the correct option will be both A and C. And the last MCQ, the second derivative test will fail when f double prime of C does not exist. F double prime of C is equal to 0, both none. Remember, second derivative test is used for the relative maxima and relative minima. For the minima, the f double prime of x is greater than 0, and for maxima, it will be less than 0. But over here, when f prime of C is equal to 0, then the second derivative test will fail. And if f prime of C does not exist, then it is also fail. So the correct option is option number C. So with this question, I finish my lecture. Inshallah, in the next video, I will solve the next chapter, chapter number 4, related with the differentiation of a vector function. Thank you for watching. Subscribe my channel, and also hit the bell icon to receive the upcoming notification about second year mathematics. Thank you.